All right, let's talk about something that feels almost magical, intuition. You know that aha moment, that sudden flash of insight that just seems to pop into your head from nowhere? For ages, we've seen it as something totally separate from cold, hard logic. But what if it's not? What if we could actually build a formal system for it? That's what we're diving into today.
And that really brings us to the big question, right? Can a machine, something built on pure step-by-step logic, ever truly have that spark of creativity, that sudden moment of understanding that we humans get? It's always felt like this fundamental wall, this line that machines just can't cross.
And this is exactly why it seems so impossible. I mean, look at how we define it. It's a leap. It feels like it completely skips all the logical steps we're supposed to take. It comes from somewhere else. Well, that's the classic idea we're going to start chipping away at today.
So, to really get the solution, we first have to appreciate just how deep the problem goes. For centuries, intuition has been this massive roadblock for anyone trying to understand the mind as a formal, logical system. Think about it. On one side, you've got rational thought. It's structured, it follows the rules, it's predictable. And on the other side, you've intuition, which feels wild, creative, and almost random. Philosophically, we've basically put them in two separate corners, like they're enemies. The real heart of this problem, the reason we've been so stuck, is how we've always pictured reasoning. We've imagined it working on a single consistent track. The source material calls this monological reasoning. And this single-track idea, it runs smack into a giant philosophical wall built by some of the smartest people of the last century. First, you've got Kurt Gödel, who proved that any single rulebook, any formal system, will always have true things that it just can't prove using its own rules. Then Roger Penrose came along and said, well, hold on, humans can see that those things are true. So our minds must be doing something that no single computer program, no single algorithm can ever do. Okay, so this is where it gets really interesting. This side kind of lays out the old way versus the new way. On the left, that's the old model, single-track thinking. It follows fixed rules and it's trapped by Gödel's theorem. But what if that's not the whole story? Over on the right, we get a little hint of the future, polylogical reasoning, a superposition of views that actually uses conflict to create something new. And this brings us right to the breakthrough. It's a whole new framework that basically changes the rules of the game by changing the rules of logic itself. So here's the core idea. What if our minds aren't running on just one logical track? What if we can entertain multiple, even totally contradictory systems of logic at the exact same time? This is the heart of what you see here. Quantum-inspired polylogic, or QPL. And yeah, it's quantum-inspired for a reason. It's all about this idea of holding multiple states, or in our case, multiple logics, in superposition at once. Let's make this real for a second. Imagine you're getting advice from two mentors. One tells you to be super cautious and play it safe. The other one tells you to go big and take the risk. Their advice is completely contradictory, right? Well, logical superposition isn't about picking one or the other. It's about holding both of their viewpoints, both of their logics, in your mind at the same time and seeing what happens. And this is where the magic happens. Because when you hold these different logical systems in your head, they don't just sit there. They interact with each other. They interfere. And that interference creates something brand new. So the process basically looks like this. First, you take your conflicting rules, like the advice from our two mentors. Second, you hold them in superposition. You don't pick a side. And third, a new idea emerges, not from either rule by itself, but from the tension between them. The framework calls this emergent inference. And this formula really captures the whole idea beautifully. In plain English, what this is saying is that the outcome of holding two logics in superposition is not the same as just adding up the outcomes of each logic separately. There's this extra bit, this interference effect. And the argument here is that this gap, this extra, that only appears when you combine perspectives, well, that's where intuition is born. So here is the most crucial, mind-bending part of this whole thing. Get this. By holding multiple logics in your head at once, you can come to a conclusion that was literally impossible to reach from any one of those logics on its own. The new idea was never in the original rulebooks. It was created by their interaction. I know, this all sounds really abstract, so let's bring it back down to earth and look at a concrete example that shows how this whole process can solve what looks like an impossible paradox. So imagine a company, and they are stuck between a rock and a hard place. They have two totally conflicting legal obligations. The emergency priority logic says, in a crisis, you must disclose all employee info. But the privacy priority logic says you must keep all that same info secret.
So what happens when there's an emergency that involves confidential information? You have to send it, and you also have to not send it. In normal, single-track logic, this is a disaster. It's a contradiction that breaks the system. It's called a deontic explosion, where basically anything goes and the logic just melts down. But what's the human, intuitive solution? It's not to just throw your hands up. It's to find a clever compromise, right? You invent a new rule on the spot. Apply a reduction protocol. You hand over what's absolutely necessary for the emergency, but you black out the confidential parts to protect privacy. And here's the kicker. That solution, the redaction protocol, it wasn't in the original emergency logic rulebook. And it wasn't in the privacy logic rulebook. It's a completely new idea, an emergent insight that was created by holding both of those conflicting demands at the same time and finding a way to resolve the tension. That, right there, is artificial intuition in action.
So the implications of this idea are just huge. This isn't just a neat new trick for AI. It's a whole new way of thinking about ourselves, about what reason and creativity actually are. This quote from the source material is really the key takeaway from this whole explainer. Intuition isn't some magical, irrational thing. It's a different, maybe even higher form of rationality. It's not a departure from logic. It's a departure from being trapped in a single logical track. And this just completely flips that old debate on its head. Remember that giant philosophical wall from Gödel and Penrose? Well, that wall only applies to single fixed systems. A polylogical system that operates in superposition just isn't playing by those rules. And that opens up a wild possibility. Maybe the human mind isn't non-algorithmic at all. Maybe it's just not monological. And that leaves us with this final, massive question. If that aha moment, that flash of genuine insight, can actually be described by a set of formal rules, then what's next? What does that mean for the future of AI and for how we understand our own minds? It suggests that maybe the line between creativity and computation isn't really a line at all. Maybe it's a space full of infinite, interfering possibilities.